Hello guys and welcome back. So now we talked about the glue constraint, which is this guy, and the other important constraint that we need to learn about is the pin constraint. To make this interactive and fast enough, I'm going to turn off the localized fracturing, so we just have this, and I'm going to copy these two guys. I'm going to create a new constraint. So let's call this out CST pin. And the pin constraint requires something different compared to the glue. The glue constraint links the two pieces based on their centroid. So the centroid of the piece here, this piece here, it creates a wire in between them. The pin constraint cannot have a length. It needs to be a zero. It needs to have a zero length. So basically the 2 points are stacked. And what it can do with this, it can use that point as a pivot to rotate and bend the pieces together. So what I'm going to do is I'm going to take this this network and I'm going to unify each of these primitives and then scale them down to 0 so they are the 2 points are overlapped on top of each other. Let's create a facet node. Okay, and let's create a primitive node. I'm going to scale the primitive to 0. So if we start scaling them down, you can see they're going all the way to 0. And this is what we need for the pin constraint to work. Even though these look like points, just points, they are actually primitives. Okay. And I'm gonna copy, actually let's connect this. I'm gonna call this my constraint 2. It's a pin constraint, but I can name it whatever I want here. Okay, let's go back into DOPS and let's disable these guys. Let's disable both of them. I'm gonna create a new constraint network and let's browse for that constraint pin. And we're going to create a hard constraint pin, hard constraint relationship. Okay, the rest length needs to be 0 because the primitive has no length. It's the 2 points are on top of each other. And let's make sure the name is correct. So let's copy this guy. And you can see it's displaying the links between the pieces. See, it's like a sphere or something. So I'm going to turn off the show object link in here. Sorry. And let's hit play. Nice. So see what happened. The wall didn't break at all, and it behaved like a rubber material. See, it took the hit. Let's see, flat wire shaded. It took the hit, it bounced, and then it went back to its original place. There's a little bit of issues there. It's still figuring out what's happening. We couldn't fix that by increasing the substeps, but we'll get to that later. Now, with this constraint, the glue constraint has a breaking force, has a strength. The hard pin does not. Okay, so we cannot break this ourselves. But we can do something custom. We can create our own break-in rule for this. And the way to do that is using a subsolver. I know this is going to be a little bit confusing, but we're going to create something called subsolver. And these constraints are primitives. They are coming from subs. And to process them, to change their data, we need to use a subsolver. So I'm going to connect that subsolver here in this third input, and this will get executed every frame. And inside, if we dive in, we have access to various data from the RBD sim. And what we're interested in is the relationship. If we click here, it sees actually importing the constraints network. And let's go back and play 3 frames, and let's dive inside and let's look at the spreadsheet. Go to and go to the primitive attribute. Now if I go back to frame 1, this is the data coming from subs. Okay, if we go to frame 2, it created some new stuff. Where this is coming from, it's coming from the sim interacting together, and every time Houdini works with this data, it creates a new attribute and stores them on these points to track various things: the force, the distance, how far they traveled, the angle, how much this constraint bend, and stuff like that. So we can use this information to break these pin constraint, let's say using the force. As the object hits, we will see an area where the force is much higher than everything else. So those infinite is probably the inactive pieces. Okay, so let's say if the force is higher than 10,000, we don't want to break the constraint, we can just change its name, because the data here is being linked via this. So if we change inside the sub, if we change this name, it will break the constraint. We don't have to delete the actual wire. So let's create an attribute wrangle, and this is going to run on a primitive attribute, because if we look here, these are all primitive attributes, they're not point attribute. I'm going to say if force is higher than, let's say, let's start with 4,000. We want, if this condition is true, we want to change the constraint name to something else. Pin broken, for example. That's it. Import the data. If that condition is true, change the value. Let's hit play. Nice. And now the pin is breaking because that threshold is met. If we click on the W key, the wireframe, and view and turn on the show guide, you'll see the constraints are still there, but they are disappearing as that constraint or rule is met. Now if we middle click here, you're going to see an error saying it cannot find a constraint for this, for pin broken. It's going to complain about that. Okay. See, it's very, very cool. And it's still very soft as well. So it's going to complain about there's a constraint missing, and what we can do is this just to keep everything clean. I'm going to add a merge node. I'm going to add a no constraint relationship, and this basically just a way to link the data and store it together, so it doesn't it has a way to be assigned in DOPS. And now it shouldn't error anymore. You can see there's no more warning. And we can change this. We can say, okay, if the force is higher than 10,000, let's go back up. If the force is higher than 10,000, break the constraint. Otherwise, don't do anything. And you see now it's more resistant, and it only break. The force is only strong enough in these areas, so that this is what happens. Cool. So this is the basic idea, and then we're going to start looking at the geometry, the high-res geometry that I have from the previous workshop. I'm going to go over the mesh and explain how it is structured, and the more complex workflow now for doing constraint. These are the two things that I use, at least in my own workflow. These are the two things, and we're going to combine both of them in the system to create something more interesting. Because right now, if you look at the data, at the result, the wall is quite soft, but we don't want it to be too soft, and we don't want it to be too solid either. So we need a way to mix these two constraints together, and I have a workflow for that we will look into when we start setting up the more advanced example. Thank you guys for watching, and see you in the next video. Bye bye.